Okay, today we're going to talk about the domain and range of functions and how to find them by looking at a picture of a graph. Right? And just as a refresher, your domain represents all of your x values and your range represents the y values. If you forget those, domain and range are in alphabetical order. X and y are also in alphabetical order. Your domain is actually any x value that I can plug into my function and receive some sort of y value. Alright? Same thing with your range. If I plug in an x value and if I can get something out of the function, all those values represent the range. The easiest way to determine the domain of the function is to take a straight edge, your ruler or a pencil, and if you want to find the domain, which is your x values, take your pencil and start sliding it across your x-axis. Right? And always come from the negative side. And once this straight edge starts to hit your function, right there at 1, that is where your domain begins. Alright? Now I'm still hitting my function, so all of this is going to be considered part of my domain, and this line, this red line, goes infinitely down the x-axis, so my domain is going to start at the number 1 and go all the way up to positive infinity. The range is done in a very similar fashion, but with the y-axis. So you're going to take a straight edge and go through the y-axis and start on the negative side, and as you can see, I'm not hitting my function, I'm still not hitting the function. All of a sudden at the number 2 on the y-axis, that's where I start to hit my function. So your range is going to start at 2, and it'll go all the way up into positive infinity. So for this problem, my range is going to start at 2 and go all the way up to infinity. Alright, here we have a parabola, and if I start to calculate or find the domain, as I drag my straight edge across the x-axis, it doesn't really look like my straight edge and my function are actually meeting, but eventually, way down in the third quadrant, they are going to intersect. And so if I continue to drag this, it will always be intersecting, and even all the way out here, it's still going to intersect. Although it's way down in the fourth quadrant, it will intersect. So for this problem, my domain is going to be all the reals, from negative infinity up to positive infinity. The range, once again, I'm going to start at the negative side, and I am still hitting my graph here. I'm still hitting the graph, so my range, this is all included in my range. I'm still hitting the graph. The only problem is at the number 2, I still hit my graph, but anything above a 2 is not included in my range. Right? So my range is going to be all the values from negative infinity, we always start with the negative side, up to and including 2. Alright, let's take a look at a final example. Once again, if I take my straight edge, I'm not hitting the function. I do start hitting the function at 6, and since that's a closed circle, I'm going to include that point. I'm still hitting the function, and at the number 5, I am not hitting the function anymore. It's an open circle, so that represents that I'm not going to include that point. So my domain for this problem is going to be all the values from negative 6 up to 5, but not including 5, so we're going to use a parenthesis. The range, as I bring up my straight edge, I'm not hitting my function, I start hitting the function at positive 1, and as I go up, alright, we'll call this point up here 4.6, we'll call that the max. Alright, I'm still hitting the function there, but anything above that doesn't count. It's not included in the range. So my range is going to start at a positive 1 and go all the way up to the y value of that point, 4.6, and we're going to include it because it's a filled-in circle.